introduce our today's speaker. So Ming Shu. So he got his PhD in experimental condensed metaphysics from Boston College in 2010, and then he moved to Lawrence National Laboratory, where he did research in RPS spectroscopy of strongly correlated systems. And in 2013, he moved to his current position as an editor with Physical Review X. And now all of us, of course, have much to do with journals and publishing. Well, I suspect each person here spends much time reading journals, and in particular journals published by the American Physical Society. And also, of course, trying to write papers. So we do research, we do some experiments, calculations, other things. And then, of course, not everything we produce is publishable, but sometimes we feel that it is. And then we invest additional effort, we write things up, discuss, polish, and finally send them to a journal. And then the data disappears in some sort of a black hole. And you wait and wait and wait and wait, and one day you get in the mail. And maybe this paper is accepted, and then it's a reason to celebrate, maybe it is rejected, which is of course the opposite, and it often feels very unfair, and in particular, it doesn't really feel that the papers that accepted and rejected are any different. When you invest so much time into them, they all become like your cherished child, right? So why was this one accepted and that one was rejected? Such a huge mistake. So today's seminar will shed light on this mistake. So let us welcome our speaker, Yiming Shu.
I know it's a Friday. After a whole week, there's a snow. I really appreciate that you can stay with me, and I hope the next hour I will try to answer 3 questions: who we are, what the kind of things we publish, and how we do that kind of things. I cannot promise that after my talk you will understand the mystery. Still, sometimes it's a mystery to me as well, but I will try to help you to understand our policy, our standard, and how we really select the papers from there. So in my talk, I will try to give you some stories that will help you to understand how we do such kind of things. So first question, who we are. So all physics review journals are published by APS, American Physical Society, which is a non-profit membership organization with more than 50,000 members. Really appreciate it. Maybe most of you here are members of APS. Really appreciate. And our ultimate goal is to advance and diffuse the knowledge of physics through research journals, which means us, physics review journals, and the scientific meetings. So we know that the biggest one will come in like 3 weeks, I think. Now it's called GPS, Global Physics Summit, because we combine March meeting and the April meeting together. We were told actually this year we will hit around 18,000 people in Denver, so another record. I don't know whether it's good news or bad news, because you will see a bunch of people hanging around on the street of Denver. But this is what we are trying to do. So beyond the GPS, we also have a demo, all this kind of division meeting. Demo is for AMO science, and also we have soft condensed matter, statistical physics. So I think more than 10 divisions. So each division will have their own meetings. So this is our goal, and you can see from the map, we almost publish everything from this country, from this Earth, planet, besides some countries in Africa. Of course, we haven't published anything from Greenland. Maybe Trump will not be happy with that, but it is what it is, right?
I have a question about
this
picture. It's like that you published nothing from Australia over 4 years.
Yeah, I think this is incorrect. So someone should update that. I'm sorry. We definitely published something from Australia. Yeah. And also in-house, we have more than 70 full-time editors. That means it's our career, and we have more than 100 academic editors with other affiliations. So they have their own primary job, but they are doing this kind of editorial work as a volunteer. And we have more than 400 editorial board members to help us And for PIR, it's called Division of Associate Editors. And they provide what they do is they really give us some advice on the paper and to be the sounding board for editors, and also to handle the peers, because we are a community-based journal, non-profit. So we do have this appeal process. So if you really feel that the paper was misjudged or there was some like editorial error, you can appeal for the decision. So it will be handled by our board member. So in general, by conclusion, is a so-called so APS can be described as by scientists for scientists. So you can see all the editors, PhD in physics, and we're working for the community. So it's really for the community. And so this is our history of the APS. Actually, I told Dima it's shame on me because I didn't know that the most important founder of APS it was in Brown University. I only know that this year the president of APS is from Brown University. That's I know, but not know the history that the almost a very important person who founded the APS was also from Brown. So my bad. Actually, something, this is a fun notes, because Dima told me I should give you some like fun information. So here's something fun to know. At beginning, you can see all the journals will have a different color, for PIR, dark green or something. So at a certain point, we were joking. The difficulty, the most challenging part for APS to launch a new journal is to pick up the color for the new journal. So you can see until PR research stopped doing that, and after that, all the PRX series, journals are using black, and the new one, the APS Open Science, they just choose gray to distinguish. And also, actually, now if you go to the journal website, you don't see this color anymore. But before, I think 2 years ago, each journal will have their own so-called journal color to label themselves. But now it doesn't exist anymore. But I, in my presentation here, still show this kind of a color information. So internally, we call ourselves as PRX blue. This is my favorite color in some way. And left side is open access journal. So that means the authors will pay for the article processing fee, and it will be open to everybody who can download the paper to read the paper. On the right side is a hybrid. That means it's a subscription based. So you need a certain IP address to access the paper, but the authors will not pay for anything. It's just the reader will pay because they need to have the subscription to read the paper. But of course, the authors can have the option to make the paper as open access by paying this APC to make a single paper. So that's why it's called a hybrid. So it's a subscription based, but a single paper can be made as open access as well. And I think, exactly 2 years ago, 3 publishers, APS, AIP, and IOP, they joined together along the so-called purpose-led publishing. So in one sentence is we are not publishing your result for money. We publish your result for science. So this is something that you can read. So we put the research integrity ahead of profit and admit our errors if there's one. So feel free to tell us. So this is pretty much for APS. And so actually, usually nowadays I don't show this slides anymore, but still people are curious where we are. Actually, before the pandemic, we have the editorial office online. The address is One Research Road. It's next to the Brookhaven National Lab. You can see. So this is the Brookhaven National Lab. Uptown is the city. You can see that's a collider. This is a synchrotron. So we're just across the street. It's a 1 mile driving from the entrance. I think this is the entrance of the Brookhaven. So it's just 1 mile driving. So we are next door, and it was very fancy building. So at the beginning, it's just this part. So in 2008, they borrowed money from APS to build this part. So this is the inside. It was a very nice building, but unfortunately, the upper management decided to sell the building during the pandemic. So now everybody is working remotely at home, and so that's where we are. And since I'm from PRX, so I just give you some like an introduction of PRX. So in PRX, we have two leadership. One is called chief editor, one is the lead editor. Chief editor is internal person who will guide the workflow, and the lead editor is a representative from the community, because again, we're nonprofit, we are community-based journal, so we need some representative. So this lead editor is from outside, who is active faculty member, will be telling us what kind of feedback we got from the community and what we should do. And also, now this person is the leader of the editorial board member as well. So the journal was launched in 2011. So 4 years later, I joined the team. And actually 2 weeks after I joined the team, we had external committee review, because again, we are a community journal. So each journal will be routinely reviewed by the committee from the community. And it was that review to decide PRX should stay small. That means we only publish around 250 papers per year, and to become very selective. So the first 3 years is really like freestyle growth, no really guidance. But it was 2014 that was the time to decide PRX should become a small journal, to be selective and to be open access at the same time. And we have Victor Paul join the team from PRB, but they are still a full-time editor of PRB, but they are helping me to handle the condensed matters submission, because for the whole team, we have a 40 to 45% submission from condensed matter community. So it's a huge load. So that's why I need additional help. And then Mauro is the editor who handles the quantum science and technology. And Yiming, I don't know how many of you knows her. She was editor of Nature Physics. We kind of recruit her from Nature Physics and try to handle the paper from AMO community. And we have Anila from Soft Condensed Matter. Raphael is academic editor, so he is a full professor, I think, in France, but he's helping us to handle some like biophysics papers. So this is the whole team. But actually, in 2024, Lin retired, so now we have a new chief editor, Grant, who was a science editor until 2024. So he joined the team in December, and now is almost 1.5 years with us. Yeah. So this is the whole team. And beyond the editorial team, we do have one consulting editor, Marcus. Marcus will not handle the paper. He gives some suggestion whether this is an interesting topic to explore. But we also have 31 editorial board members from different areas. Maybe you will recognize some faces here. Condensed matter, soft condensed matter, quantum, AMO, such kind of things. So again, what they do is really give us a comment on the paper to tell us what the community think about our performance, and also handle the peer. So, of course, each journal will have some metrics to show. What I just want to mention here is just this slogan, which was proposed by the former lead editor of PRX, Jean-Michel Lemon, a small journal for big papers to describe PRX. So small journal means we publish only 200 to 250 papers per year, which is comparable to Nature Physics. So Nature Physics publish around 200 papers a year. PRR published 2,500 papers a year. So it's one order of magnitude bigger than PRX. So we are a much smaller journal. And the big papers doesn't mean that we publish long paper. Big papers means we publish big impact, long-term impact. So in this table, I just want to mention this, emphasize this number, 5 years impact factor. So that you can see this number is close to the 2 years impact factor, which means we really focus on the long-term impact instead of this shiny, flashy result. So we hope that after 5 years or even 10 years, actually I didn't show here, we do have a 10 years impact factor as well, which is around slightly less than 15, so 14.8 or something, showing that after even 5 or 10 years, the paper we publish still have the impact to the community. So we don't really go after this 2 years one. We hope that we can publish long-term impact papers. And also, here's some metrics, so direct comparison to Nature Physics about the article influence score. So this is definition, I will not repeat. So I just want to mention, coming from 2023 to 2024, the data here, we increase from 6 to 6.2, but Nature Physics is dropping from 9.4 to around 9. So we are trying to fill the gap. So if you ask me what PRX goal, I would say our ultimate goal is become the alternative choice for you to publish a Nature Physics quality paper, but in a non-profit venue. So this is our ultimate goal. So eventually we want to become the competitor to Nature Physics. So then the next question is, what kind of paper you really publish? So here I'm going to present some examples, but of course those are so-called no-brainer paper. So each journal will publish, this kind of normal distribution papers, which you have a no-brainer answer, right? Everybody wants to publish. You have the tail that the editors regret to publish. You have the middle, which so-called backbone papers that define the identity of your journal. But here the example are from this no-brainer side, most likely, and also I'm using condensed matter cases as example, but doesn't mean that we only publish condensed matter, because I'm the one who handles the condensed matter. So I'm more familiar with those kind of results. I just want to tell you why and how we publish those papers, and to help you understand, what kind of papers we are looking for. So first type is this so-called make fundamental theoretical or experiment discovery. So back to 2015, actually, that was the first paper on so-called observation of wire semi-metal. Of course, it's not a real wire particle. It's a quasi-particle thing, the observation of a quasi-particle of wire in some quantum materials. At that time, so the first paper was a DFT prediction paper. So authors did a lot of DFT calculation, make the prediction that these materials will have this so-called wire semi-metal phase. So that paper had some difficulty to be reviewed with us because what? Because in PRX, when we have this kind of prediction paper, we need some experimental verification, especially for DFT calculation. I'm no meaning to say they are not good enough, but the thing is the entry level is relatively low, so everybody can do. So everybody can make the proposal, but to verify this kind of proposal, we need some experimental verification. So at the beginning, in the first round, actually, the referee said, okay, look, this is a good prediction. It's a big prediction, but I don't see any verification. So I don't know. This can go to PRB as reference for the next 5 or 10 years to see whether people will pick up. But actually, after the first round, the authors told me, look, there's some experimental result will come out soon. So that they send us some some preliminary experiment result, and this did help the referees appreciate their prediction, and eventually we published that paper. You can see that's March. And this is the first experimental paper from APS to show this kind of observation. But of course, the authors mess up by themselves. When they submit the paper to Science, they sort of remove some results. and published those results in Nature Physics separately. And the science editor was not happy, so they rejected the paper. But the competitor had the paper ready, and it was accepted by Nature. So the authors contact me and say, can you do the fast review and just publish the paper? I said, I cannot promise that I will publish a result, but I can do the fast review. Actually, this paper was reviewed by 2 referees in 1 day, and we got a positive signal, and we decided to publish the result. And it turned out to be a groundbreaking result because this is first experimental observation of this wild some metal compound. And this is the only topic was chosen to celebrate APS 125 years, this kind of a big achievement from PRX. All other papers were selected from PRX or physics review, but this is any topic was chosen from PRX that was published by us. So of course the third paper was like transport management to show to provide another evidence of the existence of the this quantum particle. So this is for first example, again, just to make it a fundamental discovery. So this is something that we would like to publish. The second case is not really some like fundamental discovery, but this is the first observation of this topological state in the magnetic materials. And the story here is actually 3 independent groups. They achieve the same result almost at the same time. They talk with each other because all of them are APS person. You can see they did maybe they even did the measurement in the same place. So they talk with each other, and they send me an email say, we have 3 results. We have 3 papers reporting the same thing. Do you want to consider them together? Yes, eventually we consider them back to back to back. Actually, I didn't check. This article number should be changed. It's 39, 40, and 41. I forgot to change here. But yeah, eventually we review these 3 papers together by using 2 same referee for the 3 papers. But each paper I add another referee because each paper has a slightly different focus point. So that referee is checking those kind of unique part of the paper to be sure. And other 2 referees, they review the paper, 3 papers together to make sure they are on the equal this footage in terms of novelty and importance. So the message here, again, is making some observation, the first magnetic topology insulator compound. But at the same time is if you have similar result with your competitor or collaborators, whatever, don't worry, talk with them. We will be happy to consider them together if the quality is meeting with our criteria. Okay, the third example. So we have the example, say, the groundbreaking observation. We have, say, back-to-back result. Now is something that you have some result that is similar to the result, just be accepted. So this is the case. Actually, in 2023, we published this observation of a fractional quantum Hall in twisted bilayer system. But actually, before this paper was submitted to us, on August 15, Xiaodong Xu's group posted this paper on arXiv, and I find it very interesting. I sent an email to Xiaodong, say, hey, Xiaodong, do you want to submit this paper to us? We can do the fast review, and we can just consider publish as soon as possible. And Xiaodong said, sorry, the paper has been accepted by Nature. You can see it was published actually online on August 17th. On the very funny things, on the same night when I sent an email to Xiaodong, this group's author sent me an email saying, we saw Xiaodong's preprint as well. We have a similar result, but which has now been reviewed. Can you do the faster review? Because we have almost identical result. So that paper was submitted to us, I think, before August 17. I forgot which day, but I asked them definitely before 17 because I heard from Houghton that the paper will be online very quickly. So in 1 month, we had 3 rounds of review of that paper, and eventually we decided to publish that result. So the message is, even you are schooled by some accepted paper, not even published formally, is accepted paper, don't worry, we are here. As long as it's some good paper, important paper, meeting our criteria, we will be able to publish those kind of papers. And more story coming here is actually that year, 2023. So these 2 papers are transported results. Early that year, we have 2 papers from 2 different groups. Of course, Houghton groups again on optical results, which is indirect evidence. Those 2 transported results are direct evidence showing the fraction of quantum Hall. But these 2 optical results are sort of indirect evidence. So Nature bundled them together. Even you have different publication date, which is for online only. They put 3 papers in the same volume. That means when they print out together, it's in the same volume together, which on September 27th, together with this highlight. So they have news and views to show this kind of result. But since, remember, we have a colleague who worked for Nature Physics before, so I asked Yun to talk with Nature, Cecily, to see whether they can highlight our paper at the same time, which they did eventually, kindly. So the message here is, as long as it's good science, we can collaborate with our competitors to promote the result. Actually, you can see the paper, the 3 papers, and the news reviews were published on September 27th, and together with our paper the same day. So we pick up that day on purpose because we got news that this 3 paper will be formally published on that day. So again, this is like a discovery. So the question here, a lot of people will ask, what kind of paper you really want to publish? And so this is a particular editorial from the 2D community. So we have 2 editorial board members to bring this question. See, what do you think about PRX? One was PRX is very rigorous. So papers reporting any experiment discovery are harder to get in. Another is PRX is only interested in fundamental physics, so a more materials-oriented or device-oriented paper will have trouble to get in. And maybe the third one is PRX published a small number of papers on 2D materials, so the editors might not be very interested. So is this true? No, of course the answer is no. So that's why we put this editorial out, say, to answer this question, does PRX welcome papers from this field, 2D community? The answer is yes. And also this kind of answer applies to almost every field. So again, in APS, we never pick the topic. We accept all the submissions from different community as long as you can demonstrate your novelty and importance are superior. And I'm meeting the criteria of PRX, so we will consider those papers. One of my colleagues, Paul, said, what is the ideal PRX paper? Is after you reading this paper, you would like to tee off your proposal, to write a new proposal to follow that direction. So this is ideal paper for PRX, but it's not necessary. The bar is very high. I cannot guarantee every paper we publish is such kind of paper, but at least this is kind of like our guidance to publish the paper. So to welcome this kind of a 2D community, we had this special collection on 2D materials. So far we have 7 papers. I think we are missing the last one. Most likely it will be published this month, or I think in March. So we will conclude this collection, and you can see the topic, various topic. So this collection is by invitation only. So we have a committee to select really the topic and the group and invite them to submit the paper. But still, all of the papers here were reviewed formally in PRX by applying the PRX standard. So to continue about this kind of like criteria of PRX, so we talk about the fundamental discovery, but now it's more like showing the current state of art of the field. So I show this kind of 3 papers here, which are nickelate superconductors. You know, I think right before pandemic, Huang's group have had this kind of infinite layer nickelate superconductors. This triggered a big interest because people have tried to find the superconductivity in this compound for a very long time since the cuprate. So after almost 30 years, they finally achieved that. But the result was not that reproducible. So the first paper is on the polycrystal, unfortunately, because it's very difficult to synthesize a single crystal at that time, 2024. This is a polycrystal result. Usually we don't publish polycrystal results, to be honest. But this is the first one, really show the possible mystery of the superconductivity on this compound. It's 320. It's called 327 compound. Why is the superconductivity? Why is the superconducting? And how it becomes superconductivity? Even show some phase diagram there. So at that time, it really show the most advanced result in this community. So that's why we choose this paper to publish, even it's from polycrystal. And the last year, actually, so what happened to this paper is even funny, is because his competitor just published officially in Nature the same result of this 4310 with a similar TC. And it has been published officially, but they have the similar result and talk to me, say, can you review it? And eventually we decide not only review it, and eventually we publish it. Actually, the competitor papers by Nature was published in November of 2024. So you can see almost half a year later, we still publish this paper. Why? It's really showing the new compound with the highest TC of this system. So as long as you show some great result, showing the state of the art, we will consider that. Even you have, competing paper has been published, PRX is still here to serve your need. And of course, the last paper is still on 4310, which is competitor of this group, showing the first phase diagram of this compound and giving the whole story of the superconductivity story, and also showing the highest TC. Because of that, and around the same time, we decided to have the cover image. So this paper was chosen to have the first cover image for PRX. Because we are online journal, it's not printed version like PIR. So every time you can go to the library to see the printed version. We don't have the printed versions, but we still decide to have the cover since last March. So this was the first image that we chose. And we decided to have a full cover image every 3 years, every year. So that means every 3 months. So we have the condensed matter, AMO, and the quantum physics. So if you ask me how we choose this, yes.
Can I ask you, does Presbyterian maximize the transition temperature among all rares? So did they check all rares in London? And so that's my question. So will you get a higher TC if you substitute Presbyterian with something else? Or?
Yeah, I mean, of course, not anything. I mean, the first paper is always trying to see the highest TC, but after that, we will see how to improve the TC, how to really stabilize that, and how to make the sample.
No, I understand why they use lanthan, because there is more lanthan than praseodymium. It's really lanthan and cerium, and they do have different chemistry. So one of those things, lanthan and cerium probably would have different temperatures. But praseodymium, other than producing beautiful green color of salts, is pretty much the same as lanthan chemically. So it's a little bit surprising. Is it actually very different temperature?
I was told actually yes, it's a different actually ransom by any chance it has the highest
So
one.
did they check all rare earths? Because who
No,
knows?
not yet.
Say
Yeah.
Europium is chemically also very different from the rest.
Yeah.
It can be divalent, not necessarily trivalent. It's different energetic. So maybe.
Yeah. But again,
maybe
it's
it pushes it down.
Yeah, but again, this is a high pressure one, so this might produce different result compared to our understanding. Normally this kind of pressure.
What was the logic in selective praseodymium? It's a very rare element. Why they stick to it? So lanthan, cerium, I understand. Europium at least is chemically different, but praseodymium, very rare and very typical.
For them, it's just a random try in some way. I don't know.
So they probably tried all of them, and praseodymium gives the best results.
Yeah. They try to produce as many as possible to see which one is superconductor, right? So eventually they show the highest TC.
Okay, so then we probably know the answer. Praseodymium has the highest TC.
Yeah, that's something. In some way, at least when I was a student, I call some girl as a drug dealer. They cook something, they sell something, right? Not sell, really sell. They give you a phone call, say, hey, I have something. Do you want to measure it? It's like in some way a drug dealer, right? So they just try different recipe and cook the sample and to make the sample the quality the best. It was I have the best single crystal. Do you want to measure it?
What happens if they just use mesh metal? Don't separate rare earths. Just take unseparated rare earths and build the crystals. They are chemically so similar that they'll probably still produce something and give a superconductor. Did they try that?
But it's very hard. In typical, you think, okay, this, you put everything together, it should work, but it's never the case. So sometimes you really need this kind of trick. For example, the best sample grower for cupric is Gendaku from Brookhaven, right? So I was told when he was a postdoc in Japan, and when around the time he was about to leave, his supervisor sent a student say, you just go after with him 24 hours, 7 days, to make sure you learn everything from him. Even like that, after he was gone, the student cannot repeat what he did. It's really needs some like a personal trick and experience to make things work. Yeah. So again, back to the cover. If you ask me, any criteria, it's very difficult to say. First of all, we have to consider, since any full image, we have to consider the topic to cover everything because we are broad journal. Second thing, during these 3 months, we try to pick up the most important message in that topic. And also, we have to pay attention to the image appealing because you don't want to, just two lines with atoms there. It doesn't appeal to anybody. So we have to consider a lot of things. So if your paper are not selected, don't worry. It doesn't mean it's not important. It's just not a good fit for that volume. That's all. Yeah. So at the same time, also I want to emphasize PRX also pay attention to the theoretical papers. Actually, not by default, we publish 50% to 50% theoretical with experimental result. So we find some. I give 3 papers here and talking about the different physics here. All of them, I sort of trigger the interest of the community very much. So that means unlike nature physics, usually you see experimental results there. We also pay attention to the theoretical one, which is a big driving force for a lot of experimental effort. So sometimes we don't like the theoretical paper try to explain the experimental result after they publish in Nature, but instead we prefer some theoretical paper to show possible experimental measurement that you can figure out some physics there. I would say all of these 3 papers meet such kind of description. Yeah. Again, also PRX published perspective. So far we only published, I think, 4 perspective. So 2 from condensed matter. This was the first condensed matter perspective. What I just want to mention is the perspective we publish is really want to give the people some idea to study some topic. It's not like to review some like hot topic. So unlike other journals, usually you see the perspective is you see the trend, something is happening. So they write some so-called perspective, but it's more or less a review on that topic. But for us, we really want to show the people that something can happen. So this is an example about this automatism. I know that some people still are not convinced this is a new concept, still talking about, say, this is an old concept, but defined in different terms. But if you really think about the spin group classification wise, this is, I think I'm convinced that this is a new concept. Actually, I just heard this year DOE's early career condensed matter section of early career go. I think they found all this automatism proposal. So that shows that they really realize that this is something happening, and they would like to give the money for the people to do that. Okay, so I give a lot of examples. So the question is how we really handle this paper, how we really select this paper. So this is a very famous cartoon that showing the peer review process, that as author you have your paper, you file with all different referees, and eventually you will get the paper accepted or not. But you can see there's evil at the end of the road, which represent editor, because even you have a positive report, it's still possible that the editor reject your paper. You might ask why. So my next maybe 10 minutes is trying to answer this question. So what kind of experience you can get? So first of all, it's not a really experience, it's some suggestions from editor. So when you write paper, you should pay attention to a couple of things. First of all, you should ask yourself, is this work novel? That everything is novel, I would say. Every single paper is new. Otherwise, then you are reproducing something. But how to define this novel? In which degree is novel? Again, is something that you're really making some new concept, making some new progress, new physics that will inspire people in your community to go after that. So this is something, the novelty that we would like to have in PRX. And the question next one is about whether this really is making significant progress. Again, it's just to say how important for your colleagues in your community will pay attention to your result. It's just a small group of people will care, or it's a big chunk of people will pay attention to. And I will skip the third one, but the last one is something that I want to mention. Is the paper well written? Of course, I'm not talking about grammatically, but also the presentation, whether it's coherent. So this is my suggestion. When you finish writing, you talk with your people within your community and outside your field a little bit. Why? I'm not talking, say, I have a condensed matter paper. I talk to Lucas, hey, can you look at my paper? Can you understand? Of course, I will not do that. The thing is slightly outside your field. It's still in condensed matter, but maybe doing slightly different things with you. Why is that? Because when I was a PhD student, I talked with my theoretical collaborators. I asked him, say, can you explain this process to me? He said, it's so obvious. It's so clear. Why you don't understand? I said, sorry, I don't understand. Can you explain? So he stopped doing that. He just couldn't deliver such kind of, because it's so obvious to him, but it's not clear to me. So this is kind of like a barrier between, peoples. But for a highly selective journal or this kind of high-profile journal, you have to be careful, because your paper might be read by the people outside of your community. So that's why ask them for some feedback, because sometimes you use some short-term abbreviation that you know very well. For example, I was just told by ADP, okay, it's a very common sense for the biophysics people, but not necessarily for me, right? So you have to define those kinds of abbreviation. So make sure, ask the people slightly outside your field to check your paper, to make sure that they understand what you are trying to say. Actually, as an editor, we are trained to try to summarize each paper into 2 or 3 sentences. What kind of message you are trying to deliver. So your paper should be written in this way, so can let some non-expert to grasp the message by themselves. So this is the message. Remember, the paper, you are not writing the paper for yourself. You are writing to your audience. So what we do, so I will not really say things, just mention one thing. In PRX, we do read your paper from beginning to the end. We are not just read your abstract, not any introduction or even cover letter. We read through your paper. We ask, what we do is really ask a question during our reading. Say, is this true? Is it really not done before yet? Is this technique really new? Is it something that has not been studied before? We raise this question during our reading. So we will check the reference to answer our question. If the question can be addressed with a positive, with say, if this has been done before, if the answer is yes, of course, then your paper is not good enough for PRX. If the answer show me that this is something really, superior, so then we will send the paper outside. So then this is the part that I will try to answer the question I just raised. If you have even the positive report, why we still reject paper? So again here, we are not counting the words. We read through the papers, we try to get the substance of the reports, and we pay attention to whether this is a substantiated argument, reasonable level of details, personal self-serving remarks, and we put all information together, make the so-called informed decision. So we are looking for the reasons of your recommendation. By saying that, when you nod your head, you think it's easy, but I can show you two examples here. I'm always saying writing a positive report is more challenging. Why is that? Because when you write something positively, you forgot to give it the reason. You stop saying, this is fantastic, this is outstanding work, and never give us the reason. But this is the part we are looking for. So this is one example by some referee about the paper. If you read this part, you will find it's useless to editors because you just say, okay, this is good, but you never explain why it's good. And then also, as author, maybe you read this part, a reference such as something should be good to mention. You might think, oh, this reference is from this reference. No, actually, for this case, it's not. So my suggestion here is never guess the identity of the referee. 95% you will get it wrong. And very frequently, we got so many cases to say, yeah, this negative referee is not expert in this field. You should ask the doctor who actually, but that report was written by that person. So many times. But then you ask me, what kind of a positive report you should write? Okay, I'll give you an example here. Again, this is not the report. This is the case when I have a mixed report, which means someone say yes, someone say no. So I shared this no report, the negative report, with the positive referee, and ask this referee to give me the comment of that report. So you can see this referee gave me some like background at the beginning. First of all, this referee confessed there's some conflict of interest because this referee is doing the same thing, right? So there's a bias for sure. This is very informative information to share with me, to then judge whether this, which kind of a level of conflict of interest it is, so I can make the decision there. And second paragraph, this referee was introducing about the background of this research, in which stage this research is. So to help me to understand, to appreciate the importance of the work. And eventually, this referee expanded the different opinion on the argument of the negative referee. So you can see every single paragraph, this referee gives the statement, gives the reason. So this is something that we are looking for the positive report. So if you really write something, this is a fantastic work, you should publish. It doesn't carry anything. Of course, as author, you will be very happy to see such kind of comments. But as editor, it doesn't help us a lot. So that's why sometimes you will find, even you get a positive report, the editor will still reject the paper. Because usually, when you write a negative report, you give the reason. This is something that will convince the editor, say, okay, maybe the paper is not compelling enough, right? Again, this is some suggestion for the resubmission, but since the time is a little bit limited, so I will just be short. So you can write everything you want to us, but be sure that you go back to the ground state. So when you get a rejection, of course, everybody is pissed off. So it's a so-called excited state. So excited state, what happened? It can happen collision. So don't do that. Leave it for 2 or 3 days. Get back to the ground state and read the commands to make sure that those referees have a point or not. If they are totally biased, tell us. Feel free to write everything to the editors. Of course, don't point the finger to the editor, say you're an idiot or something. This will not help you, right? But don't worry that you will send some negative input about the referee's report to the editors. Say, oh yeah, I write some complaint to the editor. So next time the editor will remember my name and will just reject my paper. No, it will not happen. We are professional. This is my career, so I will not do that. If you ask me whether I have an impression with you, yes, I will have an impression. I will remember that occasion, but that means it will bring the bad influence to you next submission. So feel free to mention what you think about the report. So we can have a scientific discussion. We don't welcome this kind of biased argument. Say, oh yeah, you have to publish my result or something like that. I just want to briefly mention, especially as an editor of PRX, what kind of challenge we have. So most of the time, we have mixed reports, so we have to make the decision based on that. And also, the good referees are overburdened. And also, I just want to emphasize the selected journal, like us, we only publish, remember, 200 to 250 papers per year. It's a subjective by definition. Why is that? Actually, back to 1960s, there's a paper about this so-called 41st chair effect. So you don't need to read everything. It's just when you have a certain number, the quota, and when you have opening of this quota, and you have so many good candidates to fill that quota, it's so subjective. So eventually, you have to make your call. But actually, almost everyone can fit that opening. But you have to, unfortunately, pick one of them. So it's a subjective process by definition, this kind of selective process. But what you can do is try to justify your selection at your best. So this is our selected journal is trying to do. We try to give you the reason why we make this decision, why we reject your paper, why we accept your paper. Something like that. Of course, when we accept paper, you don't care about the reason. You just say, hooray, you accept, right? By talking about the reference, you can see we publish around 20,000 papers per year. Think about each paper, I will have at least 2 referees and 2 rounds. You can do the calculation how many referee reports we need. It's huge. So when you complain, okay, you are slow, say why you are still holding my paper, think about whether you review the paper for us or not. Okay, it's feedback loop things. I'm not blaming anyone. I understand everybody is busy. So when you get the review request, if you don't have time, tell us. It's fine. You can say no directly. There's no hard feeling. It's even more helpful because now we know we can move on. We can find the next one, right? So this is some suggestion. As a young student or postdoc, you should work with your supervisor to get some training to write the report. And senior advisor, I know you have a lot of things. You have teaching, you have research to do, you have the department obligation. So you can involve your student, train them to write reports as well, because this is a part of a training for PhD as well. And again, so this is a QR code you can scan to register yourself. If you are not the referee for APS, you can fill the form and just register yourself, and we will use you when there's a suitable paper. But after that, make sure distinguish yourself. Of course, maybe in this room it does not apply too much. But if I go to China, I will emphasize that because we might have 10 same Chinese names in the system. It's very difficult to distinguish them. So try to do this kind of thing. So you can use Google Scholar, OK, Pablo, and the personal website to distinguish yourself. Just to give as many as possible information. And to appreciate the referee, the APS has this so-called outstanding referee, but this is mainly for senior people. It's a lifetime recognition. But now we also has this so-called general outstanding referee. So recognize what you have done in the last year or something. So far we give 2 rounds of this kind of things. And actually, okay, maybe I will quickly skip this one. So this is a referee page in our system. So everybody will be curious what kind of things we see in our screen, right? Because you don't see. So this is something that we will see. So when we try to find the referee, so we will have name, we will have the email address, we will have the expertise. And also, more importantly, each report we will grade. So you will have 3 numbers for each of the report. So first number is how quickly you return the report. So 2 means 2 weeks. The second number is define what's your recommendation. In simple, it's a higher number means you are more critical. You are saying no to almost everything. The higher number means that. The lower number means you're soft. That means you say yes to everything. The third number is the quality of the report. How helpful was this report? So the lower number, the better. So the best is 0. 2 is normal, is standard. Is a standard report that give us some information. So I have checked our system and checked for the bronze. So we have around 160 registered referees, including someone who might pass away. Unfortunately, I didn't screen those out. More than 45% referee reviewed at least 1 paper for us. Thank you so much. And also I realized we have 6 outstanding referees. And Dima is one of them. I really appreciate that. And also we have 1 editorial board member who is not here today, I guess. But yeah, really appreciate your support from this community. And that will conclude my talk here. And thank you so much for your attention. Okay, questions?
So perhaps I ask one question.
Yes.
So you spend a lot of time explaining to us how you would ignore a positive report if it's not up to a standard and will decline a paper.
Yeah.
But at least from my interaction with physical reviewers and some other journals, I'm not speaking about PRX, I got an impression that something else does to happen a lot. There are some high quality positive reports, and then there is a brief, sometimes very strange negative report, and it seems to take much more weight than anything positive. So would you comment on this?
Okay, first of all, I'm not working for PRL. I should not really answer that question. But so now I'm removing my hat of APS employee. So this as formal scientist, I'm trying to answer this question. First of all, PRLs are sending more paper out for review compared to us. So you can see we're only send out like 20% paper outside to review, but the PRL are sending out 60%, even sometimes 65% of paper out for review. And eventually they want to hold the acceptance rate at 25%. So you think you send 60% out, you want to publish 20% out, 20%, right? Eventually, so that means you have to cut 2/3 of paper. So that's why maybe as soon as they have a negative input, they will just by default to reject the paper. So they might not pay attention to the content of the report, but just by default they would like to reject more paper. But again, this is not as an employee of APS. It's really my guess because I don't really work for them. I don't know the real policy for them, how to deal with such kind of information. But as far as I know, because we are doing more this kind of a cross referee, that means sending the positive report to negative referee or negative report to the positive referee. Actually, PIR is now, they are also doing a lot of things like this, try to get a coherent input. So I think they are improving a lot of the quality compared maybe 10 years ago when I joined the APS. I think they are notifying this kind of problem. They are trying to fix the problem.
Yeah, but this actually leads to another question. So
Yeah.
you mentioned that the big difference of PRX from PRL is that the great majority of papers don't go for review.
Yes.
So the crucial step is this one.
Yes.
And this step tends to be rather non-transparent
Yeah.
to authors. So
Yeah,
could you
yeah.
comment on that? What are the rules? What
Yeah,
is
yeah.
the appeal and how is it decided?
Good question. Actually, I'm sorry I didn't spend the time around that page. So actually, what I said that we read through your paper, I mean that. So usually we spend more time on your paper. We take notes, we ask a question, we study literature, discuss it with the colleagues, and sometimes if we are not so sure, we will contact the editorial board member or even external expert to get some informal input to understand your paper and try, like what I said, we try to summarize your paper into two or three sentences and to evaluate this 2 or 3 sentences are really compelling enough for PRX. So of course, we will not tell you every single decision that we are making because our experience shows that the more we give to the authors, the higher chance you will fight back, right? So we try to minimize such kind of, we think not productive process. So we try to limit it. But for sometimes we do give you the information why we think the paper is not great enough. Especially when we talk with the editorial board member, they will give us some comments. Most likely, we will share this comment with you. We think, okay, because of that reason, we think it's not good enough for PRX. So, in short, we spend more time because we are small. We have, maximum 3,000 papers submissions per year. So technically, each editor should handle from 500 to 600 papers per year. So we have more time to spend on your paper to read through to make the decision. But for PIR, since their volume is too big, I'm not saying that they don't pay enough attention to your paper. It's just compared to our time, they are quite limited because some editors from PIR handle 800 to 1,000 papers per year. That's a lot. So I mean, compared to the time they spend on the paper, of course, maybe relatively less. So maybe their judgment could be quicker. So I don't know whether this will answer your question, but yes, we talk with people. We try to make the decision as careful as possible. So actually, each paper, not every editor in PRX will do that, but most of the paper, we will write down our assessment in a paragraph and to say why I think this paper is not good enough. Of course, by saying that, don't ask for those kind of documents next time for your submission. But yeah, I can tell you, we do have such kind of documentation there and try to follow that. Actually, Nature Physics also do that. Yeah.
Okay.
Yeah.
So can I ask, how separate are the review processes at the different physical review journals? So if I submit to PRX and it goes through a round of review, and then you decide it's not significant enough for PRX, and you say you should publish in PRB instead. Then does PRB see
yes.
everything that you've already done? And,
yes.
Okay.
Yes. We are using the same system. That means once your paper is in, every editor can see what happened. Even this paper is not in your journal. So if you have a friend who works in PRC, you ask him, can you check where the reference report is? How soon I can expect the report? This editor can find all the information. So, but he should not tell you anything about that. But I just want to give you an example that everybody who has this access to our system can see what happened there. So every single event happened during the process will be recorded. So who did what, who said what, will be recorded from the beginning to the end. Because eventually the appeal process, one part of appeal is to check whether there's any misconduction. Yes.
This might be hard to answer because it might differ case by case so much, but what's typical amount of time from submission like to publication per se?
I think soon we will publish this kind of data, but I think for PRX it's longer. I think it's more than half a year. So maybe 180 to 200 days or something like that. But to be honest, this is also not because of us, because sometimes you need to prepare the resubmission. So sometimes orders take a longer time, but actually a lot of orders forgot that they took a very long time. They blame us, delay the stage, because as soon as you receive, you don't hear anything from us after 1 month, you might be panicked, especially student. I was student. After 1 month, I would be very panicked. I would check the status, manuscript status almost every day, right, to see whether there's a new report coming in. But actually, this will not help you a lot. So in PRX, actually, we go after this referee very frequently. So we will send a reminder almost every week to go after this referee to make sure that they don't forget about that. So we try to minimize. So I would say each round, typical length is 40 days. So I would say 4 to 6 weeks, something like that. Yeah. So we try to, at least for me, the first decision is made within 5 days of the submission. That means when you submit the paper, logging to my queue is not, it does not immediately show up in my queue. It takes a few days to be processed. Mm-hmm. So as soon as it shows up in my queue, that's the beginning of the stage. I will make the decision, first decision within 5 days. The first decision means rejection, send out for review, consult some person. All of this action called a major action. I try to do it within 5 days. Yeah. So this is my best promise I can give. Even when I'm traveling, I try to do the same thing.
Thank you.
Sure.
Okay, so let us thank our speaker again.